Hello, I'm Meredith Blackwell. I'm at the IMC 12 in Maastricht, Netherlands. And today is August 14th, 2024. And we're here to interview people for the oral history for Mycology. And we have now Nancy Keller, who is going to tell us about her career and start out with her early life and how she got interested in fungi. And it's amazing, but Nancy is someone I only met last month. I should have known her long ago, although I knew of her work. So, Nancy, go ahead.
Well, thank you. Do I just ramble for you?
Yeah, you start out when you were born and where.
Yeah, well, I was born in State College, Pennsylvania. So I am a Pennsylvanian. Always feel loyal to Pennsylvania.
Was there an affiliation with the university?
No, actually not. So, humble beginnings. My dad was a car insurance agent, and Mom was a homebody, took care of the kids. I feel she would have been happier had she a career. She's a very smart person. In fact, I have to tell a little story about her first. When I was in graduate school, so I'm jumping ahead a little bit, but I'm thinking of Mom. I got my doctorate in plant pathology at Cornell University. And Mom and Dad came to visit me towards the end of my career. And my advisor was Olin Yoder. And so they both were talking to Olin, and he's trying to tell him what I was doing and cloning DNA and expressing a gene or deleting a gene for virulence in fungi. It's the beginning of the DNA revolution. And I could see my dad was bewildered. Dad just smiled and said, yeah. And Mom said, oh yeah, DNA, the double helix, that was, and she started talking about Watson and Crick, and I had no idea she knew that. She'd read it on her own. It made me feel proud, but also, sad, maybe missed opportunities.
Yep.
So anyways, both of my parents were very proud of me. I think I was always inclined towards science. I didn't know fungi, because I did a lot of experiments when I was a kid. I was always doing experiments, but they could be biology, or I remember making a robot once that didn't move, but early robot.
But it looked like one.
It looked like one. I'd say sociology experiments with our dog, all sorts of things, but I did botany. I remember I'd read how you could fuse a potato and a tomato together, and I tried it. Didn't work very well, but I was always doing things like that, very curious, which some of my relatives thought I was too curious. Really interesting, the response of relatives to you. But I was very definitely inclined to be a scientist. And what inched me towards fungi actually was my Peace Corps experience. So after I graduated in biology, I was thinking maybe of going into medicine, becoming a doctor, but I didn't want the atmosphere of a hospital after all. So I went to the Peace Corps just to get a little adventure. I like adventures. And when I was in the Peace Corps, one thing that became obvious to me, and actually had a big impact on me, was that sometimes the food supplies were bad. So I worked at a mission. It was actually a Catholic mission. That's a whole nother story, which I'd love to go into, but would be deviating from science for a while. But my students would get free food from Europe and the United States, and sometimes the food would go bad. So they had this meal, sort of a maize meal, along with some soybean flour to be mixed together for a porridge. And I can remember it got really bad, so the storage supplies were run by the nuns, but they let me go in because I was a science teacher. So what I found is that there's these bags and bags and bags of maize meal, and when in a dark storage container, and when you opened the door, it's like, I don't know, gazillion rats jumped out of it. And then the bags were all contaminated with rat feces, but you could see mold too. And that always sort of stuck in my head. I thought, oh yeah, that's bad food.
Where was this?
This was in Lesotho.
Okay.
Lesotho is a teeny little country landlocked by the Republic of South Africa. So, so as while I was in the Peace Corps, I decided, okay, I want to go to graduate school. And one of the advisors in the Peace Corps in Lesotho had gotten his graduate degree from Cornell. He said, oh, Nancy, Cornell University is a fantastic university, a lot of international ag. Because I thought, oh, I'll get a master's and come back to Africa. That was my thought. And after talking with my advisor in the Peace Corps, I thought, I'm going to enter plant pathology because this is where I could study when foods go bad. And so I started to get this feel, though I wasn't 100% sure I wanted fungi. But when I entered Cornell, I was at that time assigned. We didn't do a rotation. And I became the first student of Dr. Gary Bergstrom, who's just a fantastic mentor. Yes, I'm Gary's first student. And I started working, he had a project, a field project on looking at Calototricum leaf blight of maize and stalk rot of maize. So that was my master's, and I fell in love with fungi then. Calototricum is a really cool fungus, but I love all fungi. And, you know, I had this master's project that was very applied. And as I was working, though, I just became entranced because I'd go to seminars and I'd hear, oh, it was just then that people were starting to say we could clone a gene or we could find a gene in a fungus that was important in virulence, and it just intrigued me. And so I said, you know, I'm going to stay for a PhD. And for my PhD, then I kept Gary as a co-advisor, and Olin Yoder became my other advisor. And I had a molecular study where it's so primitive in ways when you think of what we do now, but it was simply to ask, if you put foreign DNA into a fungus, will it alter its fitness? It really was a fitness test. So we found that it did, actually. And it was probably the transformation procedure itself that gave the fungus a little negative impact on its fitness for a while. But I just became more and more intrigued. And by working with the genes and with fungi, and I knew I wanted to stay with fungi. I worked with the Cochleobolus heterostrophus, a leaf blight pathogen, for my PhD. And a key incident that happened when I was a graduate student, which put me on the path of mycotoxins, was when I was, I don't know, probably fairly senior in my PhD, Dr. Paul Nelson, who had been, a professor at Penn State and worked on fumonisins in South Africa. He worked with Willie Marazis way back then. He came and gave a talk about this Fusarium mycotoxin that caused leukoencephalomalacia, if I'm saying that correctly, which I'm probably not. I do not pronounce well.
No, I think you're close.
I'm close. I'm close. And what got to me is this toxin called fumonisin was produced in high amounts in the area of Africa where I'd been a Peace Corps volunteer. And I even started thinking, man, did I eat some fumonisin? Maybe that explains me. But that turned me. I said, okay, I want to find a postdoc where I can work with mycotoxins, because it also allowed me the vision of being maybe to help in Africa and other countries again. So I specifically looked for a postdoc on mycotoxin, and I also wanted to do my molecular stuff too, and there weren't that many at the time, but I ultimately joined a lab in New Orleans with the USDA, and they were looking for somebody to do some protein work, which I'd never done in my life, but I thought, oh, well, that'll be a new skill. So I joined the lab of Ed Cleveland and Deepak Bhatnagar, who are working on aflatoxin. And my role, which I successfully did, was to purify an enzyme in the aflatoxin pathway. And I did. It was a penultimate enzyme in the pathway that converted sterigmatocystin to aflatoxin. So we were able to clone that, and then through reverse genetics, sequence the protein and use oligomers to fish out the gene. I mean, you don't have to do that anymore, but that's what we did. And we were able to find the gene that encoded the enzyme, and this helped lead to, as I was doing that, I was looking for a professorship, and there was an ad from Texas A&M where they were looking for a new assistant professor in mycotoxins. And meetings are important. I went to a Gordon conference, and the chair of the department, Dr. Neil Van Alphen, was there. He heard me talk about purifying the enzyme in the aflatoxin pathway, and he came to me at the meeting and he said, "Nancy, why don't you apply for this position at Texas A&M?" So I did, and I was hired. And it's everything I tell you, it's just lessons I learned. One thing I learned from Olin Yoder is Olin said, "Nancy, use a model system if you can to answer your question, because model fungi have advanced genetics." So keeping what Olin said in mind, and then Joan Bennett came in and influenced me. Everything built in my life is from having great influence. So when I was a postdoc at the USDA, I met Joan Bennett, who was a professor at Tulane working on mycotoxins, and she had done such fantastic parasexual genetics where she showed that the genes in aflatoxin had to be linked through the parasexual genetics. And then she also helped point out to me that Aspergillus nigelans, a model Aspergillus, made sterigmatocystin, which was the precursor to aflatoxin. And I said, then taking what Joan had found, what Olin told me, why don't I go to Aspergillus nigelans and try to clone the gene cluster in Aspergillus nigelans rather than worrying about Aspergillus flavus, or parasiticus, which wasn't as easy to work with. And indeed, when I went to Texas A&M, another person who influenced me, there is an excellent Aspergillus nigelans researcher, Tom Adams, and Tom had gotten his PhD, or was it his postdoc? Now I forget. Maybe the postdoc on the molecular genetics of Aspergillus nigelans. So I started working with him, and hey, my first 2 years we cloned the entire Aspergillus nigelans sterigmatocystin gene cluster, which is the start of a lot of very cool data. And it went on from there. We asked how it was regulated, and found first the transcription factor that regulated the gene cluster, and it was the same in the aflatoxin pathway, AFLR and flavus. And then I'd ask, well, what regulates the transcription factor? And we found this gene that's sort of famous called LAA. LAA is conserved in all filamentous ascomycetes, and it regulates not just aflatoxin, but most of the secondary metabolites in any fungus. So, that changed my trajectory. I've always continued with trying to understand how aflatoxin and other mycotoxins are regulated, but I expanded my vision to, let's just see how natural products are regulated. And it's gone on from there. I don't know if you want any more at all.
Well,
but that's a lot.
Yeah, so you were at Texas A&M.
I was Texas A&M for 9 years, and then I was recruited by the University of Wisconsin. And I wasn't sure. And that was a tough one. It was a tough one. It's very flattering, but I also was a new mother, and that's not easy to do as a single mother. But I did make the move. It was difficult at first, I must say it was difficult. But you know, life is everything. It's your own personal life, it's research, it's science. But it worked out. I've always had great help. And what I did do when I moved to Wisconsin, I asked my lab too, I said, are you willing? Because I'm not going to go without you. I had some really great students. And they all said, let's go to Wisconsin. Yeah.
Did they know there was a lake where you could sit out on the campus and drink beer?
Oh, they probably did. I don't know. But they all said, yes, let's do it. And when we came, it happened at that time. It was sort of funny. I had one postdoc who could not come because her husband taught high school in Texas A&M, but I arranged that Anna could stay in the lab, and the rest of the lab came, and they happened to be all men, so they were called the Keller boys. They set up everything for me. They were so helpful, and you know, I gave, okay, Demetrius, you do the glassware, you know, Young Chang, you do the enzymes. So they put the lab together. And it worked out. It worked out well.
Yep.
And I've been there ever since. It's a very rich university, very good collaborations, and the fungal community has grown to be so many collaborations and excellent people there. It's been a lot of fun.
Now, warfarin came from there, didn't it?
Pardon me?
Warfarin, which is a rat poison, isn't it?
Yes, yeah.
And it's warfarin is an acronym for, isn't it?
WARF, Wisconsin Association Research Foundation.
Yeah.
It made Wisconsin quite a bit of money.
Right, and it was used as a rat poison, which maybe would help your people. And so,
If you didn't, yeah, well, I have a story on that too. I mean, you have to be careful with that because I had some problems at my house, and I think it was warfarin. I got these little cubes for some mice. I probably shouldn't say that. Oh, people are going to be hating me. I'm sorry.
You can drop it. You can drop it.
Okay, drop that one. My
Yeah.
dog accidentally ate a cube.
Oh my
Never
gosh.
used it again. Got him to vomit. So.
Oh, good.
Yeah.
Because I know that for a while people were thinking, oh, this is a drug that can give you longer life. It's a fountain of youth drug.
Oh,
And
really?
I
No, I
actually
didn't
had
know
heard of I think it was a student at the University of Toronto who actually died because it causes bleeding.
Yes, it causes
And
bleeding.
that's how it was first discovered. It was in clover, I think, that some animals were eating, cattle probably, and somebody came into the university to help solve the problem. So
interesting.
I may be getting it mixed up, but I think it's something like that. So it's a toxin produced by a fungus on clover, right?
No, I'm not sure about that.
But anyway, we need to look it up because it might be a good story that fits in with everything you've been talking about.
Well, what for sure fits in is the penicillin story at the University of Wisconsin.
Mm-hmm.
So I am the Kenneth Raper Professor. And so Kenneth Raper, which I can, very well, he was the chair of bacteriology before I arrived.
Yeah.
Maybe he probably passed.
Oh
I'm
yeah,
not quite-
I think he had died before you were there.
So he did a lot of interesting work, but one thing he worked on was penicillin production. So as we all know, when penicillin was accidentally discovered by Fleming, supposedly, a spore of penicillin fell in a petri dish and inhibited the bacteria. Did that really happen? I guess it did, yeah. And it was recognized, well, this compound could actually be used to treat bacterial diseases. And so when World War II, I mean, this is an old story, everyone knows this, came, well, the problem was they couldn't make enough penicillin. So, and now here's another story, I guess it is true, we've all heard this, is the USDA lab in Peoria, that one of the technicians found a moldy cantaloupe.
Moldy Mary.
Yeah, yeah. But,
which is supposed to not be so, but
yeah,
it makes a good story.
I don't know. But Kenneth Raper actually worked with the Peoria scientists to help develop this strain to be a massive penicillin production. So a lot of the research occurred at Wisconsin. And right outside my building, I'm at the Microbial Science Building, there's a plaque to honor Dr. Raper and all of his colleagues on getting enough penicillin production for World War II. And so that's a natural product, right?
Yeah, yeah, I think it was, and they found it on a cantaloupe.
On a cantaloupe, they say.
Yeah.
I believe that's the case.
Yeah.
Yeah.
And it just might not have been Mary who found it, but they actually, there's a mural, I think, in Peoria.
There is, yeah. Well, we actually have the original mural at Wisconsin.
Oh, okay.
Yeah, so I was
Neat, I
talking
didn't
to
know
the
that.
current chair of bacteriology, and I said, oh, doesn't Peoria want that? So Peoria has one too, but I was told that the one we have at Wisconsin is the original one, and the mural is based on this original picture, which I don't think Wisconsin will ever give up. So if you want to see the original picture of...
Well, I once had this idea that we should have biological historical markers, and I was going to put one at Peoria to commemorate, you know, the improvement of penicillin.
So, just as we have, it has to be shared, Peoria and Wisconsin. Yeah, definitely.
But anyway, I couldn't get any money from the National Science Foundation education people, but we had all these places picked out where we could put biological markers that had to do with fungi.
Oh, what a wonderful idea.
We might do that someday in my later days of retirement. But also getting back to your grain stored in Lesotho.
Yeah.
What, were there not any insects in there besides the rats?
Oh, I'm sure they were insects. It was like,
But-
once the rats jumped out, I sort of wanted to jump out too.
One of the first
Yeah.
times I ever got money at LSU was, and it probably saved my career because I was slow getting started once I made the move, but I got lots of corn that had been grown all over the world, and I was supposed to look for it. It's supposed to be a study to decide which corn strains were best to grow so that they wouldn't get moldy.
Yeah.
And so we got all this stuff, and they brought it to Baton Rouge, and I was supposed to grow it out and look for fungi that might produce mycotoxins. And it was so full of insects.
Yeah.
And so I figured, you know, it's not going to be a good study if they're mixing up all the strains by these bugs.
Yeah, no, insects are huge. Of course they are. They vector the fungi and they chew in, and the fungus will come through. That's
Anyway,
true.
this all affects our lives a lot.
Yeah, no, it really does. I mean, if you think of just mycotoxins alone, because, you know, I got my degree in plant path, so I always want to keep one little plant path project going, though more of my research now is really the ecology of all fungal natural products. It's so cool. I mean, they're there for the fungus to secure its niche in so many ways. But so going to aflatoxin, one of the big deals, in fact there's some talks here, it's not just aflatoxin, is the concern, of course, with climate change and how that's going to affect the different mycotoxin producing fungi. Are they going to be moving around? Or definitely, I know with aflatoxin there's a greater concern as we're basically getting warmer, it's moving up. There's a very nice study, oh boy, I should know who wrote it. Felicia, what's her name? Okay, you know me. Okay, cut some of these things out, right? And I'm not remembering the names here, but she's done some excellent predictive studies in the Midwest in the United States. Man, the aflatoxin problem, which used to be mostly in Texas and, you know, the southern states, Georgia, Alabama. Yeah, they're predicting Kansas, Nebraska, they're going to be socked. We're even going to get some up in Wisconsin. So,
Canada.
yeah, it's so.
Moving north.
Yeah, it's moving north, and
along with the armadillos.
and the armadillos, probably the fire ants too. I didn't enjoy that experience. So that's a concern there, but yeah, it is. I'm yeah. Well,
Anyway, you're
Yeah.
doing work that will apply to help people.
I hope so. I found applied science to be much harder than basic science. That's like you can find out how these toxins are made, what regulates them, but how do you take that information to actually make a solid control strategy? It's harder. Applied science is harder in my.
Yeah, and a lot of people don't want just you to do it. They hire someone who can go out and take the technology to
Yeah, but
the farmer, but you miss something out of that.
yeah, and it's just not obvious always. I mean, so one thing these mycotoxins are there. The fungus makes so much of these metabolites because they're helping it in some way. So it's going to be hard making. I know there's different ways to try to take care of the problem, but destroying the toxin. But to really stop the fungus from making them, I know there's a toxigenic strain employment, but it's useful for the fungus. So
Yeah,
yeah,
they do better with it.
yeah, it does better with it. So it's going to resist attempts.
Well, Nancy, this has been really fun, interesting. Thank you for
Well, and thank you
talking to
very
us.
much too.